Hello everyone, welcome to this course, Computer Architecture for Undergraduate Student. My name is Koo. I'm an instructor of this course. Actually, I plan to provide this course in real-time streaming classes using Zoom, but recently the servers in Korea universities are under DDoS attack, so university recommend to provide recorded classes. This is because the network in Korea universities the status is not good, so I provide these recorded classes, and then I will also use Zoom to meet you in real time and then for interaction. But I decide to provide the recorded classes for until the DDoS attacks are resolved. Sorry. So welcome to this course, and then let's go on. Okay, so this is the first class of this course. So I will briefly introduce about this computer architecture course. So let's talk about the object of this course. The object of this course is exploring computer system architecture at an abstract level. Please focus on the word abstract. I will explain later about this word, but as a computer engineering students, you should know the meaning of word abstraction. This is very important term used in computer engineering field, and then I will explain the meaning of this abstraction later. And then I know many students are not computer engineering students, and then I found that in the attendance sheet, some students are from non-computer engineering field. And I believe they are also interested in this computer engineering field and the computer engineering study. And so for those students, I recommend to study very hard. For some students, this computer architecture course may be difficult because this is the first course that to explore the computer system hardware. For some students, computer systems are just a consumer device, such as the a bit like TV or some smartphone or some gaming console. So actually, computer systems are everywhere. Everywhere means that the computer chips or CPUs are deployed in every electric devices. But we use these consumer devices like some dumb boxes, like a black box. So not dumb, but it's a very conveniently, because we don't need to know about the inside of these consumer electric devices. Also, even the smartphone, we don't know about the inside of the smartphone. Smartphone is actually the computer systems, but we use smartphone very conveniently and without any knowledge of this smartphone. But in this course, we will learn about the computer architecture. That means the inside of the computer system. So if you are not familiar with some terms or some knowledge of the computer engineering field or computer science field, please study hard. Please try to understand some difficult terms, and please try to understand some abstraction level of the computer systems. Okay. study hard. So, and then I will explain what will be covered in this course. Sorry. So this is the architecture course for undergraduate students. So I will cover the basic concept of computer systems. And then in this course, I will cover the performance metrics. The performance metric means that it's the some measurement unit that that measure the performance of the computer system. And actually, the goal of the computer architecture is to make better computer systems or better computer hardware. So what is the better computer hardware? A good computer hardware, high performance and low cost. But in order to determine some level of performance of computer systems, we need to define the performance metrics. So I will explain in the classes, the future classes. Also, I will cover the instruction set architecture. So actually, originally, instruction set architecture is called the computer architecture, because this instruction set architecture defines the behavior of the computer hardware, and then also this instruction set architecture defines the some translated computer machine language from the high level language. So this is some interface between computer software and computer hardware. So instruction set architecture defines some architecture of the computer processor. So I will cover that instruction set architecture and the machine language. And then I will cover the arithmetic logic and the number system of computer systems. And then I think if you took the digital logic design course in the previous semester, then I believe you already learned about the arithmetic logic and the number systems of the computer hardware. Actually computer use the binary number systems because the computer just handles the it's a digital signals 0 and 1. So I think this is just a review of the previous course. So I will briefly just cover this arithmetic logic and the number systems, and then I will cover the processor architecture, the pipeline architecture. This is the very important topic in this course, pipeline architecture. So you need to understand what is pipelining and then why pipeline architecture is deployed in the computer processor. Also, another important topic in this course is memory hierarchy. So memory system is very important in the computer system because every data used by computer processor is stored in the memory systems, like DRAM or some storage devices such as hard disk drive or SSD, solid state drive. So actually our data, all of data is stored in the memory hierarchy. It's a memory system. It's called the memory system. So this performance of the memory system actually determines the overall performance of computer systems. So this understanding memory hierarchy is also very important. So pipelining and memory hierarchy are two important topics that will be covered in this course. Sorry. And then parallel process architecture. So actually, in order to improve the performance of the computer system, we use the parallel process architecture, and most of the CPU deployed in the computer system, even the smartphone processors use the multi-core processors. So that is the parallel processor architecture. Then in this course, I will use computer organization and design written by David Patterson and John Hennessy. And then there are three different versions of this book: MIPS version, ARM version, and RISC-V version. Among these three different versions, I will use the RISC-V edition. Have you ever heard about the RISC-V processor? So actually, ARM processor is very popular, and then MIPS is the traditionally popular processor. But how about the RISC-V? Actually, the RISC-V instruction set architectures are recently developed by David Patterson and John Hennessy, the author of this book, this textbook. Actually, the RISC-type processors are originally invented and developed by Patterson and Hennessy. If you are interested in some processor architecture, then you may have heard about the RISC-type or CISC-type processors. What is the RISC and CISC? RISC means the reduced instruction set computer, and then CISC is the complex instruction set computer. So RISC is some simpler instruction type computers, and so this type of computer uses some simpler instruction set architecture. So so in this textbook and in this course, we will cover the RISC type instruction set architecture, RISC-V. Actually, the RISC-V is the open source architecture, so this architecture can be freely used by academia and then also in industry. So this is the open source architecture. Actually, the structure of this instruction set architecture is also simple because it's the RISC type instructions. So I believe you can easily learn about this instruction set architecture. Okay, so for this course, I will use the lecture slide. So I will use the architectural simulator for RISC-V. So in this course, some project can be provided to a project to implement some RISC-V processors using system Verilog. So this is my recommendation. Study hard and work hard for this course. Okay, this is the photo of the author of the textbook. So when they are young, actually the David Patterson and John Hennessy are one of the most famous computer architects. They designed the first RISC processor concept with their graduate student at UC Berkeley and Stanford University. Can you see this book? This is the some first edition of this textbook. Oh, this is the quantitative approach, not this undergraduate course textbook. Actually, the quantitative approach is the textbook for the graduate course or advanced computer architecture course. Also, this computer architecture or quantitative approach is also the classic of the computer architecture textbook. Then I also learned from this book. It's an old book. Yeah, this is the some recent photo of the David Patterson and John Hennessy. Who is David Patterson? He's the David Patterson, and then he's John Hennessy. They received the Turing Award in 2018. And then Turing Award is the most prominent award in computer science field. And then the Turing Award recipient provide the Turing lecture during some conferences, and then also they provide the Turing lecture during the ISCA conference, ISCA 2018, and then you can find the Turing lecture video link here. Actually, I will post this slide on the Blackboard and then Piazza, and then also you can find this Turing 2018 lecture during the ISCA conference. This lecture is very helpful to understand the history of the computer processor. So if you are interested, I recommend to watch this Turing lecture. It will be very helpful. Okay, this is the prerequisite of this course. This is just a recommendation. So the prerequisite of this course is the digital logic design. It's a COSE211. Also, you need to know about the basic knowledge on programming language such as the C. So I believe many students learned Python because the Python is easy language, easy programming language, but actually the C language is more close to the machine language. C is also a high level language, so like Python, but C is closer to the some system level language. Actually, most of the operating systems, such as Linux operating system or Unix, is written in C language. So if you have knowledge on C language, then you can easily understand some structure of the computer programming or some system programming. Okay, I will introduce myself. My name is Gu Konje in Korean, and then my office is in Ujong-Jongbogan 403. And then I set office hour from 1:30 p.m. to 3:30 Monday. And then this is my email address. So if you have any questions, you can email me. And then this is my homepage, konjegu.com. And then my research area is generally computer architecture research, and then my research lies in the GPU architecture, memory storage systems, embedded systems, accelerator, and FPGA. So if you are interested in my research, then you can apply for the undergraduate researcher, like a 학부 연구생. Okay. Okay. So for this course, I will use the Blackboard. It's a KU. It's called the KU LMS. It's a Blackboard, and then I will use the Blackboard for announcement and assignment. Also, I will post the lecture slide and then video lecture links on the Blackboard. Also, I will provide some pop quiz during the lecture, and then actually this pop quiz is just very short. Pop quizzes are composed of very short questions. So, and then these pop quizzes will be provided during the class, and you need to submit the answers of the pop quiz on the Blackboard. So I will use the Blackboard for this course management tool. Also, and then I will also use the Piazza. Piazza is the class management and discussion tool. This is the address of the Piazza for this course. So piazza.com, korea.h.kr for 2020 and COSE222, 222. And then for sign up, in order to sign up this on the sign up Piazza, you need the access code, and then access code is the COD risk 5, computer organization and design risk 5 is the name of this textbook. And then please join as a student, not instructor or TA. Please join as a student. And then you can post any questions and then answers on the Piazza. Actually, this is the discussion tool, and then everyone can post their own questions and then answers. Actually, TA or I answer for the questions on the Piazza, and this is the fastest way to get answer from me or TA. So please post your questions on the Piazza. Also, there are mobile apps for the Piazza, and you can download the mobile app from the Google Play or Apple App Store. So you can also use these mobile apps for Piazza. Also, I will post some lecture slides and then course materials on the Piazza too. So please use the Piazza actively. This is a very good tool, and then most of the foreign university use the Piazza for the course management, class management, and the discussion tool. I think actually it's more convenient than Blackboard. So actually there are many functions in Blackboard, but it's not easy to use the Blackboard functions. But Piazza is easy to use. So please use the Piazza for question and answer Q&A. This is the tentative grading policy. So I plan to provide 2 exams, midterm and final exam, and then about 4 assignments after each chapter. Also, I plan to provide some project, some mini project to design processor using System Verilog. And then there will be 5% attendance score. Is a POP using and then this attendance score is determined by POP quizzes. So score of the POP quizzes. Also, I may consider some online discussions, like some active participation for this course using Piazza or some Blackboard. But normally, I will only use the POP quiz scores for the attendance score. So exam. So I plan the on-site exam. Actually, the university also recommend the on-site exam, but it depends on the coronavirus COVID-19 situation. If the COVID-19 situation gets severe, like step 3 situation, then on-site exam will be cancelled. So, but I don't want that situation. So I hope the COVID-19 situation will be resolved. But the situation is getting worse, and then the weather is getting cold. The situation may be worse than the summer. But I hope the COVID-19 situation, pandemic will be resolved soon. Yeah, as everyone hopes. And then basically the exam is the closed book exam, and then electric devices are not allowed except a basic calculator, and then any cheating may result in F in this course, so do not cheat. Also, you can answer in Korean or English for exams. Also, you can ask questions in Korean during the class. This is the, even though this is the English course, the teaching in English is my duty, not your duty. So you can use any languages. I can understand Korean, so I can understand hopefully English, but not any other languages. But so you can answer in Korean or English during the exam. Also, you can ask questions in Korean or in English. Okay, these are the tentative schedule. No, this is the 16 weeks course, like not 15, because the last week is the final exam week. So it's a 16 weeks. And you can read the schedule of this course. And then class will be cancelled during the Chuseok holiday. Okay. So any questions?